Hi viewers, welcome to LMS Solution. Today we are going to see about control of BLDC motor by using fuzzy tuned controller. This is a Simulink model we developed for fuzzy tuned PI speed control of brushless DC motor. This simulation model consists of voltage source inverter, BLDC motor, and then decoder and getting pulse generator, and it is having feedback loop. Here we are measuring the speed of the BLDC motor. It going to be compared with the reference voltage. Here you can see that the rating of the BLDC motor is 1 kilowatt BLDC motor with the 3000 RPM rated speed. And here you are measuring the Hall sensor. The Hall sensor when we converted into a back EMF by using this table. Here you can see that the table for converting Hall sensor into back EMF. When the Hall sensor of A, B, C will be 0, the back EMF will be 0. When that Hall sensor output A will be 0, P 0 and C will be 1 means, so this is a pattern you have to generate 0, minus 1, plus 1. Based upon this truth table, you have to convert that logic into back EMF by using AND logic and some concept. Finally, you will get back EMF from that decoder logic. After decoder logic, the back EMF will be converted to gating pulse. That means here you have to convert voltage source inverter that will be act as a electronic commutator for BLDC motor. Based upon this table of back EMF, you have to convert that the control logic, that means switching logic for 6 switches from Q1 to Q6. For that we have to use this logic. So just you have to compare with 0, that means greater than 0, less than 0 with each back EMF detail, and finally you have to will get to 6 pulse from here. This will be used to control this inverter, and here we are going to control the BLDC motor speed. For that we are going to alter the input voltage of the voltage source inverter. Here you have to adjust the voltage of the input voltage of the BLDC motor by means of the fuzzy tuned BA controller. For that already told right, we are measuring the speed of the machine in RPM and we're going to be compared with the reference speed. And inside you can see that this is the fuzzy tuned PA controller. We have fuzzy logic control. So this will be receive error and the rate of change of error. The output will be Kp and Ka, and finally it going to be added with that will multiplied with the error, and it going to be multiplied with the error, and finally here we have integrator. Finally we are adding that proportional term and integral term. Finally we will get the modulating signal. I am going to show that the fuzzy detail here. Already create the fuzzy logic rules for the speed control. Here you will see that this is the input error and rate of change of error. This is value of Kp and Ka, and it will be related with the around 24 rules. Here you can see the surface V of the different rules. This is for Kp and this is for Ki. We created the rules for the speed control of BLDC motor. Now here I am making some conditions. So here initially you are having torque load which is equal to 0 Newton meter. After 0.1 second the torque load will be changed to 3 Newton meter, and then you have to check the response. And here we are making speed reference is 3000 RPM, and here you can measure the VDC voltage, and then here you can measure the line to line voltage across that after that inverter. Here you can measure the stator current and the IMF, and here you can measure the rotor speed and the torque optimization. Now I am going to simulate the model. Before that I am going to align this response. Here I am going to simulate this model. Here you can see this is stator current and this is EMF of the BLDC motor. So here you can see that the speed is maintained at 3000 RPM, and then here is load adding in that BLDC motor. Because of addition of that load, the speed is maintained around only 3000 RPM because of that fuzzy tuned PID controller. And also here you will see that variation of and Kp Ka. Here you will see that this is variation of Kp Ka and the variation of the output of fuzzy tuned PA controller. And now I am going to test the model with the change in reference speed condition. Now I am going to simulate the model. Initially system in 3000 RPM. Now I am going to change this value to 1500. Now you can see that the speed comes to 1500 RPM, and also you can change the see that changes in the back EMF of the machine. Now I am going to simulate this model from 1500 to I'm going to change to 3000 rpm, and then you have to check the speed, torque and the current details. Here you can see that speed change from 1500 to 3000 rpm because of that fuzzy tuned PA controller. For changing speed command, the controller will be track the actual speed of the machine to the reference speed, and also you can see that the difference, that variation of electromagnetic force in the EMF in the BLDC motor. We will see that the frequency and the voltage level is going to be vary according with the reference speed command and the tracking of that speed by using that fuzzy tuned PA controller. This is the working of this model. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon about upcoming videos. Thank you so much. Bye bye.